Hi everybody, today we will be seeing about transfer functions, the baseline of PIDC. So what are transfer functions? Transfer functions is the ratio of the Laplace transform of the input deviation variable to the Laplace transform of the output deviation variable. Mathematically, the transfer function can be written as the output divided by input. If we look at another way to write the same equation, it can be written as input into transfer function is equal to output. That is, the transfer function is the one that converts the input from one form to another, or it changes its magnitude. Now let us consider an example. Let the magnitude of the input be equal to 1 and the transfer function be equal to 2. Then the output would be equal to 1 into 2 equal to 2. By the way, whether you're typing in your phone or scrolling in it, or Iron Man is flying with his suit on, there are transfer functions in all of them. If you remember, in the definition of transfer functions, we had used the term called Laplace transforms. But what are these Laplace transforms? Why do we have to use them? Let us assume this to be the transfer function of a controller. And if we have to differentiate it, we would be like, ooh, that's bad. Don't worry, Laplace transforms to the rescue. As the name suggests, transforms means we're going to transform one operation to another operation. That is, we'd be converting these complex differentiations into simple multiplications by use of Laplace transforms. The function and relationship contained in a transfer function is often expressed by a block diagram representation. The arrow entering the block is the input variable x of s and the one leaving the box is the output variable y of s. We could say that the transfer function g of s in the box operates in the input function x of s to produce an output function y of s. Generally, the input to the transfer function is a forcing function, and the effect of the transfer function on this forcing function is obtained as the response as the output of your transfer function. Forcing functions are the input given to the transfer functions. The forcing functions force the transfer function to produce a corresponding response. The forcing functions can be related and are much similar to the environment in which the controller or the final control element which consists of these transfer functions are present. There are four main forcing functions: the step function, the ramp function, the impulse function, and the sinusoidal function. Let us understand forcing functions with this example. Now, to measure the temperature of this water, which is at 39.5 degrees Celsius, we use this thermometer. Once the bulb of the thermometer comes in contact with the water, the temperature suddenly rises to 39.5 degrees Celsius and then becomes constant. This is similar to what we had observed in the forcing function of step functions. Similarly, all other chemical engineering operations can be correlated with one or the other of the forcing functions. In the next video, we will be seeing about the different orders of transfer functions. Hope you liked the video. Thanks for watching.